What if the worst-case scenario about 3I Atlas is actually that it is not leaving our solar system? What if this close passage is a deceleration maneuver that we cannot detect? Imagine an advanced intelligence for which imitating natural orbital motions is child's play. A civilization that can send surveillance tools disguised as comets, asteroids, even space debris. The speed and chemistry of 3I Atlas, more advanced than anything we have seen before, may be a sign not of an alien formation, but of an alien intention. What if, at the moment it gets closest to the Sun, it is preparing to operate its hidden systems and get ready to complete the mission that brought it here? And what if it is deliberately hiding behind an ever-growing curtain of haze so that we cannot see it? Tonight, we step into the speculative shadows where natural explanations collapse and cosmic paranoia takes root. The real question is not whether 3I Atlas will go. The real question is this: will we be able to notice the moment it chooses not to go? What comes to your mind when you hear the words worst-case scenario? Maybe a giant asteroid hitting Earth? Maybe a nuclear war? Have you ever thought about the possibility of something even bigger than these scenarios happening to you? However, for this mysterious interstellar object called 3I Atlas, the worst-case scenario could be very different from what you have seen in Hollywood movies. On July 1, 2025, Chile's Atlas telescope detected an extraordinary visitor coming from outside the solar system. Astronomers, at a completely unexpected moment, encountered one of the greatest discoveries in the history of astronomy. This interstellar comet, also known as C/2025 Atlas, earned the title of the third interstellar object discovered by humanity. After Oumuamua's passage in 2017 and 2I Borisov's visit in 2019, the arrival of 3I Atlas brought up completely new questions. The hyperbolic orbit of this comet clearly defines it as an object not bound to our solar system. 3I Atlas was like an information capsule coming from the other corner of the universe. Shooting in from the constellation Volans at 130,000 miles per hour, a speed so fascinating that it would cross the United States in less than 3 minutes. Observations from the James Webb Space Telescope revealed that this visitor was unusual not only in speed, but also in chemical composition. 3I Atlas was chemically quite different from previous interstellar objects. Its CO2-dominated spectrum, deviating from normal comet behavior, left scientists astonished. But what if these natural explanations are misleading? NASA's official stance is clear. 3I Atlas, a natural interstellar object, poses no threat to Earth. Even at its closest passage on October 29, it will remain 270 million kilometers away from Earth. However, despite all of NASA's assurances, the other catastrophic scenario never leaves our minds. Mathematical certainty is reassuring, but the real concern is not physical collision. This alien comet tracked by the Hubble Space Telescope displays classic cometary behavior. Solar radiation vaporizes the ices in its nucleus and forms a glowing coma. 3I Atlas may seem to be quietly gliding in our sky right now. Radio telescopes worldwide detect only natural emissions, and where there could be artificial signals, there is silence. The frequency of discovery suggests that the galaxy is full of such wanderers, because in just the last 8 years, 3 interstellar objects have entered our galaxy. There must be many more interstellar objects for the possibility of them even reaching our galaxy to be so high, scientists think. But of course, this was valid in the natural scenario. The debris, left over from planet formation around distant stars, is thrown into space by gravitational violence and doomed to wander for billions of years. As The Guardian aptly pointed out, 3I Atlas is a cosmic curiosity, not a catastrophe. A reminder that we live in a universe far stranger and more interconnected than everyday life suggests. This ancient visitor opens a window to us from the deep galactic past. But what if the real mystery is not what secret it carries, but what secrets visitors of the interstellar object type could reveal about their true nature? Its largely different chemical composition raises these questions. What if 3I Atlas is the one to slightly open that door which will completely change humanity's knowledge of the universe? This thought experiment takes us far beyond the safe borders of scientific consensus, into speculative realms unreachable by telescopes. The math is clear, the observations consistent, the results reassuring. Yet sometimes factors can emerge that even numbers cannot account for. This cosmic visitor, 3I Atlas, whether intentional or not, comes in peace. But now the moment has come to deliberately step out of the safety of scientific consensus and into the realm of pure speculation. From here on, future discoveries like 3I Atlas should be understood not as threats to our bodies, but as scenarios that challenge our understanding of the limits of what is possible. And perhaps we will learn that we are not alone in the universe. Perhaps the universe is far more crowded and far more intelligent than we ever imagined. The true interstellar comet, 3I Atlas, remains a fascinating natural phenomenon, ancient, fast, chemically unusual, but entirely comprehensible within our current scientific framework. Whether this understanding is sufficient remains an open question, but future observations will, in the cold clarity that only evidence can provide, ultimately answer. The numbers alone shatter the imagination. 3I Atlas is moving at 130,000 miles per hour, about 150 times faster than a powerful rifle bullet. That is such an immense speed that before we could even blink, 3I Atlas would already have passed us by. The hyperbolic excess velocity of this ancient traveler with interstellar object status is 61 kilometers per second, a speed it retains even after accounting for the sun's gravity. This momentum, unchanged through billions of years of galactic wandering, is like a whisper from the depths of the universe. This speed completely overshadows previous interstellar comet visitors. While Oumuamua traveled at 26 kilometers per second, 2I Borisov came at 32 kilometers per second. It is as if each new interstellar object arriving in sequence was in much more of a hurry than the last. 3I Atlas, however, is moving almost twice as fast. Is this increase a coincidence or the result of a violent ejection from its birth system? or perhaps the effect of multiple gravitational encounters during its galactic journey. Determining the size of C2025N1 Atlas is a difficult struggle because of the glowing coma hiding its nucleus. Is 3I Atlas a gift the universe has sent us? Or could it be a far greater surprise? 3I Atlas seems to be hiding behind a curtain of mist, as if to keep us from seeing it. Current estimates range from 0.3 to 5.6 kilometers, from the size of 3 football fields to the size of a small mountain. This uncertainty arises from assumptions about surface reflectivity and coma production efficiency. The smaller estimates seem more likely based on typical comet parameters. Yet even 0.3 kilometers is a significant body. This size uncertainty may conceal not just our measurement problems, but hidden possibilities that could be far more important than size itself. The survival story of this alien comet raises fascinating questions. How did 3I Atlas survive for billions of years in the wild? How did it avoid colliding with anything? How did it escape being swallowed by something? Was it clever enough to survive all catastrophes? Or could it simply be chance? How could such a relatively modest body endure millions or billions of years in interstellar space after the violence of ejection? Small objects are more vulnerable to tidal disruption and high-speed collisions with cosmic debris. The most fascinating aspect is that 3I Atlas is likely of extreme antiquity. Long before humanity, long before Earth, long before even our solar system was born, 3I Atlas had already embarked on its immense journey. And perhaps we are witnessing the final days of this interstellar traveler. Analyses suggest its origin in the thick disk of our galaxy, in an older stellar population when the Milky Way was young and chaotic. If true, this visitor may have existed billions of years before our entire solar system. It may carry within its core the records of galactic evolution that emerged when the universe was half its current age. Literally, 3I Atlas is like an ancient memory. Can you imagine how many years back we could go if we could learn the hidden treasures it carries along with its billions of years of journey? Despite its immense speed and mysterious past, 3I Atlas with interstellar object status does not form a dynamic threat. At the very beginning of the journey, we thought 3I Atlas was dangerous because of its speed. But later we understood that in fact what kept us safe was this very high speed. Its hyperbolic orbit, which marks it as interstellar, also guarantees a safe passage. It moves too fast for solar capture. The closest planetary approaches are measured in astronomical units, not in kilometers. Observation windows present challenges. The universe seems to want us to learn about distant realms with 3I Atlas, and at the same time emphasize that it will not be easy. Brightness reaching a peak of 11th magnitude under perfect conditions still requires a telescope. During the closest solar approach, the body disappears into the glare of our star right when it becomes most active. What emerges is a portrait of cosmic resilience, ancient, fast, and transient. Do you wonder what doors this powerful combination will open for us? 3I Atlas embodies the intersection of impressive physics and ordinary risk. It reminds us of a universe operating at scales that dwarf daily experience, yet following laws so precise that the position of this visitor could be predicted years in advance. When we dare to ask what lies beyond these predictable orbits, The chemical anomalies revealed by the James Webb Space Telescope raise new questions. Perhaps the anomalies seen from the James Webb Telescope are the beginning of a much greater secret. What speculative worst-case scenarios arise? Ones that have nothing to do with orbital mechanics and everything to do with cosmic revelation. When the James Webb Space Telescope's infrared gaze examined 3I Atlas on August 6th, it revealed something extraordinary. That night, they discovered something that not a single person on Earth had known could even be possible before. A coma dominated by carbon dioxide with an approximately 81% CO2 water ratio. This was not only unusual, it was unique in comet chemistry. But as we prepare to move beyond chemical analysis into the speculative realm, does this molecular signature point to purposes and origins far beyond natural formation processes? Typical interstellar object behavior follows predictable scenarios, like unwritten invisible rules the universe sets for its own wanderers. Water ice shows dominance, sublimating at modest temperatures to form classical water vapor comas mixed with dust. Carbon monoxide appears later, then carbon dioxide and trace compounds. Molecular ratios tell stories of formation conditions and evolutionary history. Yet 3I Atlas completely rewrote this scenario. For the first time, we saw that something we thought could never be possible actually could. Breathing CO2, like atmospheric production on an industrial scale. Does this deviation from the norm open the door to speculative scenarios that challenge our assumptions between natural and artificial origins? The numbers become even striking given the observation distance. The James Webb Telescope was like a giant eye in the universe. 3I Atlas was more than 3 astronomical units from the Sun, well beyond Mars, when the James Webb Telescope captured its spectrum. Most comets show very little activity at these distances. Yet this object produced a detectable CO2-dominated coma extending hundreds of thousands of kilometers from its nucleus. What should such a highly CO2-dominated coma mean to us? But does this unexplainable activity become the basis of speculative scenarios about energy sources, internal mechanisms, and purposes that go beyond what we naturally understand to be possible? Several theories attempt explanation. 3I Atlas may have formed near the CO2 snowline of its natal star. Or perhaps we should broaden our thoughts a little further. Perhaps 3I Atlas was once a kind of star we did not know before, a place where carbon dioxide preferentially condensed from the protoplanetary disk. Alternatively, extreme age and cosmic ray processing may have altered the surface chemistry, forming radiation-processed crusts that sealed in water but allowed the more volatile CO2 to escape. A third scenario involves insulating dust mantles that developed over geological time. Are these billions of years of dust mantles something nature bestowed, or a planned design, acting like cosmic insulation that prevents water access but allows the more volatile CO2 to leak out? Yet no matter how plausible all these natural explanations may be, do they miss the most disturbing possibility? That this chemical signature represents something deliberately designed for purposes we do not yet comprehend. The James Webb Space Telescope's near-infrared spectrograph detects molecular fingerprints with extraordinary sensitivity. So much so that it can meticulously see beyond distances we would not even dare to call imaginable. When sunlight heats the coma, molecules emit light at specific wavelengths, revealing the chemical composition. The observed 81% ratio represents one of the most extreme CO2 enhancements ever recorded in comet observations. But when we push beyond spectroscopic measurements into the speculative realm, could these molecular signatures encode information far beyond simple chemistry? Indicators of purposes that challenge our assumptions about cosmic intelligence. This is not entirely unique. The comet C-2016 Pan-STARRS also exhibited atypical volatile ratios with unusual concentrations of carbon monoxide and nitrogen. Is this a standard natural model, or could it simply be coincidence? Such chemical outliers suggest comet formation more diverse than theories assume, or dramatic post-formation processing that altered surface compositions. The value of 3I Atlas lies in its representation of chemistry from entirely different stellar environments. 3I Atlas is like a photograph of what lies beyond the universe. While Pan-STARRS formed under conditions we can model, this visitor carries chemical signatures from processes around different stars, possibly billions of years ago. Alien comet geology delivered right to our doorstep. Ongoing observations will determine whether CO2 dominance represents the bulk composition or a surface expression. Each passing day, 3I Atlas spreads out a little more into its surroundings. It opens itself a little further. As solar heating increases, if water ice lies beneath CO2-rich surfaces, the molecular balance may shift. This chemical detective story surpasses the features of 3I Atlas itself. Each incoming interstellar envoy shows us a different side of the universe. If interstellar comets routinely display exotic compositions, then planet formation around other stars produced a wider diversity of icy bodies than exists in our system. This chemical diversity arriving from beyond the solar system tests theories of planet formation and evolution. Perhaps the universe contains far more formative power than we can even imagine. If theories of icy body formation and evolution are correct, they must explain the diversity observed in interstellar object visitors. At the end of our roughly 2,000-word investigation, it turns out that the worst-case scenario assumed for 3I Atlas is surprisingly ordinary. Hollywood disasters are not waiting for us. In other words, the scenarios where we are swallowed by a meteor remain only in cinema movies. There is no collision threat to end the Earth, nor is there a gravitational disturbance that would knock our planet out of orbit. The cold and precise laws of celestial mechanics deliver a verdict that allows us to sleep in peace. The orbital calculations of interstellar object 3I Atlas completely invalidate human concerns. But was this the only threat 3I Atlas posed to us? The Earth approach distance of comet 3I Atlas is a critical safety parameter, 1.8 astronomical units, or 270 million kilometers. This distance exceeds twice the closest distance between Earth and Mars and more than 50 times our lunar distance. In our solar system, such safety buffers make interplanetary collisions nearly impossible. Observations from the James Webb Space Telescope indicate that the object will reach perihelion around October 29, roughly 1.4 astronomical units from the Sun, positioned between the orbits of Earth and Mars. These calculations are not rough estimates, but precise orbital solutions that account for major planetary gravitational effects, relativistic effects, and subtle perturbations from radiation pressure. It was mathematics that gave us the assurance of these calculations, and it is also thanks to mathematics that we can be certain we are safe.
When astronomers state that 3I Atlas poses no threat, they speak with confidence backed by centuries of celestial mechanics experience and decades of tracking potentially hazardous objects. As much as alien comet speculations may be intriguing, they are powerless against the laws of physics. The speed that initially seemed alarming, exceeding 130,000 miles per hour, actually works in our favor. Objects on hyperbolic trajectories moving at such velocities cannot be captured by solar system gravity. It is as if the solar system had installed its own security system to protect itself from unwanted interstellar intruders. 3I Atlas is moving too fast to hang around and cause trouble. After performing its cosmic flyby, it will return to interstellar space. There are important distinctions in risk communication within the navigation of space agencies. The word interstellar carries an emotional weight unrelated to real danger. Primitive brain responses to approaching unknown objects clash with geometric realities. The vast scales of space and the mechanics of orbits conspired to make such encounters not dangerous, but fascinating. Could it be that every disaster scenario we fear within ourselves is, on a cosmic scale, completely unnecessary? The case of C-2025N1 Atlas shows how scientific risk assessment is conducted in the modern era. NASA's communications strike the perfect balance, acknowledging scientific significance while emphasizing the absence of danger. Clear, jargon-free language explains why this object is noteworthy without portraying it as a threat, preserving public interest in real discoveries while avoiding unnecessary alarm. Previous visitors in the interstellar object category provide additional context. Oumuamua, despite its unusual behavior in 2017, posed no threat, while 2I Borisov, in its 2019 passage, displayed predictable cometary activity. As if to say to us, you do not need to be afraid of us.
Our current understanding provides a satisfying foundation. We know its speed, its orbit, and its unusual CO2-rich composition. We have evidence pointing to great age and thick disk galactic origins. Multiple telescopes worldwide provide detailed observations of its chemistry and physical behavior. These known characteristics paint a picture of old, fast-moving, chemically unusual, but fundamentally natural comets. With every new piece of data, our knowledge about 3I Atlas grows stronger, while at the same time we understand the universe a little better. And upon reflection, we generate new ideas. Important unknowns remain. Definitive core size estimates range from hundreds of meters to several kilometers. Explanations for CO2 dominance between surface versus bulk composition remain unresolved. We cannot precisely identify its birth star systems or reconstruct the exact sequences of gravitational encounters that shaped its current trajectory. These unknown mysteries motivate us to continue our investigation of 3I Atlas, making us wonder what we will discover in future observations and leaving us deeply excited for our journey of discovery ahead. Critically, none of these unknowns affect risk assessment. James Webb Space Telescope data, instead of supporting alien comet theories, confirms natural processes. Visual evidence tells consistent stories. Hubble's images show classic comet signatures. Webb's spectra reveal unusual but natural compositions. Every spectrum line is actually like a DNA spiral left behind by 3I Atlas. 3I Atlas seems to leave us a clue to understand itself. Ground-based observations track emissions developing in a predictable way. Artificial signals, thermal signatures, or controlled maneuvers do not appear in the data. Every measurement points to the same results. 3I Atlas represents what it appears to be, a natural comet carrying chemical signatures of a foreign stellar environment, while behaving according to universal physical laws. This universality confirmation represents one of the deepest discoveries of astronomy. This confirmation is proof that the laws of physics also work in the other corners of the universe. The worst-case scenario defined by measurable physical threats to Earth has been completely refuted. Mathematics stays clear, observations are consistent, results are reassuring. This cosmic visitor, even if we cannot know whether it is intentional or not, comes in peace. The interstellar comet phenomenon manages to arouse curiosity instead of anxiety. But now comes the moment when, from the safety of scientific consensus, we deliberately step into the realm of pure speculation. We cross that fine line where imagination meets science. Worst-case scenarios take completely different forms, not threats to our bodies, but challenges to possibilities that go beyond the limits of our current understanding of physics. While the safe passage of C-2025N1 Atlas is guaranteed, doors are opened for other kinds of speculative scenarios. Maybe the real mystery is not the secrets it carries, but the secrets it may reveal about the true nature of interstellar visitors and the possibilities lying beyond speculative scenarios that telescopes cannot reach. Safety comes not from the absence of threat, but from the understanding of the unknown.
At the point where the boundaries of science meet speculation, the most critical question we must ask about 3I Atlas stands before us. What is the biggest secret about 3I Atlas? All the data we have strongly supports that this interstellar object is a natural comet, but one fact that the history of science has taught us remains. The most extraordinary discoveries initially come from the most ordinary-looking objects. The biggest question emerging before us about 3I Atlas appears exactly at this point. Data collected by the James Webb Space Telescope shows that this visitor, also known as C/2025N1 Atlas, exhibits classic comet behavior. Solar radiation sublimates the ice in its nucleus, creating a glowing coma, just like other comets in our solar system. Radio telescopes detect only natural emissions and silence where artificial signals could be hidden. But do these data really show us the full picture? Astrophysicists like Avi Loeb from Harvard approach this question from a different perspective. Loeb gained attention for his unconventional interpretations regarding Oumuamua and is now discussing similar possibilities for 3I Atlas. This perspective is by no means proven fact, but it emphasizes the importance of scientific openness. Occam's razor, that fundamental principle of scientific reasoning, strongly supports a natural explanation. The simplest explanation is often the correct one, and 3I Atlas fits perfectly into the natural interstellar comet profile. Should this reassure us, or should we focus even deeper? Because the greatest discoveries have emerged from the most ordinary-looking things. Could that be the case with 3I Atlas? Its spectroscopic signatures are consistent with sublimating ice. Its orbital mechanics are predictable, and its thermal behavior aligns naturally with solar heating. However, the history of science is full of surprises. When pulsars were first detected, they emitted such regular radio signals that for a short time they were called LGM, little green men. At that moment, we almost began to believe we were not alone in the universe. Fast radio bursts puzzled astronomers for years. Sometimes nature turns out to be far stranger than our initial assumptions.
What should we look for to evaluate the alien comet possibility? The first sign would be coherent radio emissions, structured communication signals that are unnatural.
Natural processes produce radio noise across wide frequency ranges in space, but artificial transmissions concentrate energy in narrow spectral lines, just like an infinite version of a lightsaber in Star Wars. The second critical signature would be non-gravitational accelerations that cannot be explained by outgassing. Natural comets usually show small orbital deviations due to sublimating gas, but these deviations should be connected to solar heating patterns. If 3I Atlas shows velocity changes that cannot be linked to gas production, this could be a sign of a propulsion system. The third sign would be engineered light curves, how the object's brightness changes over time. These variations could reveal secrets about itself. Natural interstellar objects typically increase in brightness predictably as they approach the Sun. An artificial object, however, may display brightness variations according to different rules, indicating controlled orientation changes or the operation of active systems. So far, none of these artificial signatures have been detected in 3I Atlas. Radio telescopes found only the silence of space and the natural emissions expected from sublimating cometary material. Its orbit obeys gravity rules without unexplained deviations. So does this finding reassure us? Brightness variations correspond to patterns observed in other comets that rotate and respond to solar heating. When evaluating the alien comet's chemical composition, 3I Atlas's carbon dioxide dominance alone does not suggest an artificial origin. Natural processes, such as radiation processing, formation near carbon dioxide snowlines, or the development of insulating dust mantles, can produce the observed chemical signatures. But could the mystery behind these lines be that simple? The transition from being chemically unusual to artificially constructed requires evidence that no natural process can explain the observations.
Lessons from the Oumuamua experience are critically important here. The first confirmed interstellar object sparked intense speculation due to its unusual elongated shape and slight acceleration. I remember the whole world held its breath at that time, trying to understand what this interstellar traveling foreign object was. Radio telescopes conducted extensive searches and found no artificial signals. Detailed analysis of its motion revealed that sublimating water ice could account for the observed non-gravitational forces. This pattern offers a valuable approach. Be open to extraordinary possibilities, but demand extraordinary evidence. This is exactly why the scientific method works. It subjects all hypotheses, conventional and unconventional, to the same rigorous standards of evidence. Speculative scenarios about artificial origins require responsible media coverage with clear labeling and proper context. When media outlets discuss the possibility of 3I Atlas being artificial, such discussions should be clearly identified as speculation rather than established science. Even the slightest misunderstanding could snowball and cause societal panic. Future observations will continue to test these speculative scenarios. As 3I Atlas approaches perihelion, additional spectra may reveal chemical signatures difficult to explain with natural processes. These are precisely the spectra we are after, the deepest hidden secrets that 3I Atlas possesses. Sensitive astrometric measurements could detect orbital anomalies suggesting controlled motion. Long-term monitoring could reveal behavior patterns inconsistent with passive comet activity. However, the burden of proof lies with those proposing artificial explanations. The natural comet hypothesis has the advantage of consistency with known physics, established comet behavior, and the observed characteristics of previous interstellar object visitors. And so far, it has not deviated from this advantage in any way. Breaking this consensus requires evidence that clearly demonstrates the inadequacy of natural explanations and positively supports artificial alternatives.
Engaging in this intellectual exercise of considering possibilities should not distract from what 3I Atlas actually represents. Even as a natural interstellar comet, this ancient traveler carries information about stellar environments we have never visited, chemical processes that occurred billions of years ago, and the deep history of our galactic neighborhood. This is extraordinary enough without requiring exotic explanations.
Now we are deliberately stepping from the safe boundaries of scientific certainty into the realm of pure speculation. The scenarios you will hear in this section will be speculations about 3I Atlas that could occur and, if they did, would produce the worst outcomes. If you have the courage, continue watching. Everything we explore here should be understood as a thought experiment rather than proven fact. Even though all evidence points to 3I Atlas being a natural interstellar object, let us push the speculative limits to see how quickly our cosmic perspective could change if our assumptions prove insufficient. The dark forest hypothesis arises from both science fiction and serious SETI discussions. One of the scenarios that frightens us most is the dark forest hypothesis. It takes its name from Liu Cixin's famous novel, but represents a real philosophical position about the nature of cosmic civilizations. The idea suggests that advanced civilizations may deliberately hide from one another, operating under the assumption that revealing their existence and capabilities could invite predation from more advanced neighbors. This could be the hidden reason why we have received no signals from our galaxy or the universe so far. Now let us consider a completely fictional scenario. 3I Atlas is not a natural interstellar object, but a type of reconnaissance probe. This possibility implies that our solar system has been surveyed by intelligences capable of designing objects that can endure billions of years of travel, and that these objects remain practically indistinguishable from natural phenomena. Imagine that the technological marvels we admire could be mere child's play to them. Consider the engineering requirements such a scenario would entail. A probe disguised as a comet would have to perfectly mimic every aspect of natural comet behavior: the correct spectroscopic signatures, appropriate outgassing patterns that respond realistically to solar heating, surface properties reflecting light consistent with natural ices and rocks, the most perfect false identity possible for roaming the universe. Could even the carbon dioxide-dominated composition of C2025N1 Atlas, according to James Webb Space Telescope data, be part of this camouflage? Perhaps its creators deliberately designed the chemical signatures that we perceive as unusual, causing us to question the true nature of our observations. Could they be playing with us? The most terrifying possibility is that 3I Atlas could start deploying secondary objects, smaller probes separating from the main body and positioning themselves throughout the solar system. Like dandelions scattering seeds in the slightest breeze. One could establish orbit around Venus, another around Mars, others distributed in the asteroid belt or positioned at gravitationally stable Lagrange points. Suddenly, our solar system would host a surveillance network of unknown origin and capability. This hypothetical scenario would immediately become humanity's greatest diplomatic and strategic challenge. Unlike the gradual first contact scenarios frequently depicted in science fiction, discovering an active surveillance network would confront us with the reality that technologically superior intelligences are already operating in our near-cosmic neighborhood. And then we would know that we could never view the universe the same way again. Governance questions would be unprecedented and urgent. Who speaks for Earth? The United Nations, major space agencies, individual countries with advanced space capabilities, or the scientific community that made the discovery? The complexity of achieving global consensus on such an important matter would stretch the imagination. Harsh circumstances have a reality that can unite people.
The active SETI debate triggered by our interstellar comet observations would suddenly shift from a theoretical discussion to urgent practical concern. The SETI community has long debated the wisdom of listening for signals from other civilizations rather than transmitting into space. Some argue that declaring our existence could potentially draw unwanted attention from hostile aliens. Hypothetically, if 3I Atlas and its secondary probes are actively studying human civilization, our response itself would become part of the data being collected. Silence could be interpreted as wisdom or fear. Every action we take would influence our timing in unraveling the mysteries on this journey, and every step we take might be analyzed in detail by them. Attempts at communication could suggest aggression or curiosity. Even internal debates about how to respond would reveal fundamental aspects of human nature and social organization to any observing intelligence. Crisis communication challenges would be extraordinary. How do you inform the global public of the existence of an alien comet surveillance system without triggering panic? How do you maintain scientific objectivity when faced with risks that could involve the future of human civilization? Questions like these would never leave our minds. The scenario would likely unfold through expert meetings, emergency sessions of scientific organizations, and a series of carefully prepared public briefings. Governments would have to balance transparency with stability, providing enough information to maintain credibility while preventing social upheaval that could result from confirming humanity's first contact with non-human intelligence. Misinformation would become a critical concern. Even the suggestion of interstellar object surveillance would spark countless conspiracy theories, false flag accusations, and claims of government cover-ups. Social media would be at the center of all this speculation, spinning out of control. Distinguishing legitimate scientific observations from baseless speculation would become crucial for maintaining a rational public discourse about one of humanity's most important discoveries. The technological implications would be equally profound. If 3I Atlas reveals capabilities beyond our current physics, it could provide insights into propulsion systems, energy generation, material science, or communication methods that might advance human technology by centuries. Perhaps all the technology we currently possess and proudly showcase could become obsolete overnight. How would we feel in such a scenario? Assuming the intelligence behind the probe allows us to survive and advance, the scientific gain would be extraordinary.
Perhaps the most unsettling aspect of this speculative narrative would be the temporal implications. If 3I Atlas has been traveling for billions of years, it could represent the technology of a civilization that achieved interstellar capability when our galaxy was fundamentally different from its current state. Perhaps it is a trace left behind by a powerful, technologically advanced civilization that existed billions of years before us. This probe-launching intelligence may no longer exist, leaving only automated systems to carry out its mission across deep time.
This silent visit of 3I Atlas from the dark reaches of space may be evidence of perhaps the most unsettling reality we face in the universe: galactic silence. This interstellar object is not just a comet, it is a messenger raising much deeper questions. Is it normal for our galaxy to be so quiet? Does this silence unsettle you as well? When confronted with the terrifying simplicity of the Fermi paradox, we face an astonishing truth. If the galaxy should be teeming with life, where is everybody? This question was first posed by physicist Enrico Fermi during an ordinary lunch conversation in the early 1950s, but its impact has deepened with each passing year. Have you ever looked up at the sky and asked yourself this question? If so, leave a star in the comments. The Great Filter Hypothesis suggests that along the long evolutionary chain from simple chemistry to spacefaring civilization, there is an extremely unlikely, extremely dangerous step where nearly all attempts fail. This filter could appear early in the transition from inert matter to self-replicating systems, or later, when civilizations develop technologies that can destroy themselves faster than they learn to use them wisely, perhaps at the point in history where we currently stand. What if the era we are living in now is one of humanity's most critical times in terms of space? According to spectroscopic analyses from the James Webb Space Telescope, the extraordinary age of C-2025 N1 Atlas, potentially billions of years, places it within the galaxy's thick disk population. This represents a period in deep galactic history when the Milky Way was young and chaotic, and stellar populations, chemical abundances, and cosmic conditions were significantly different from what we observe today. If that feels unsettling to you as well, leave a star in the comments. Timescales within the solar system are almost incomprehensible. Human civilization, from the first agricultural settlements to our current space age, spans roughly 10,000 years. Recorded history covers maybe 5,000 years. Our technological civilization has existed for only a few centuries. Yet 3I Atlas, if artificial, would represent technology operational for millions of times longer than all of human civilization. This possibility is both exhilarating and sobering, while also stretching the limits of our imagination.
This raises profound questions about technological durability versus biological survival. Perhaps we are encountering probes continuing to operate long after their creators have vanished. Cosmic message bottles floating through the galaxy, carrying information from civilizations that solved the technical challenges of interstellar communication, but ultimately succumbed to other forms of the Great Filter. Perhaps billions of years from now, our own fate will be similar. Yet, if that were the case, it would feel comforting to know that, by chance, 3I Atlas was noticed by us, and that there might be someone billions of years later to remember us. If you agree, leave a star in the comments. In a scenario where an interstellar comet is designed as an alien comet, consider the engineering requirements for creating such technology. Technology that remains functional for billions of years would require material science, producing components as durable as diamonds, energy systems operational longer than the lifespan of most stars, and software architectures capable of adapting over geological time and self-repairing. If 3I Atlas is the product of a technology, it is natural to think this is a technology far beyond what we can even imagine. The success of such engineering would paradoxically demonstrate the extraordinary technological capabilities of its creators. Any civilization capable of launching billion-year interstellar missions would have already solved countless technical challenges we have not even begun to tackle. They would understand materials at the atomic level, energy generation and storage on cosmic scales, and computation over deep time. Do you think, perhaps, the home of 3i Atlas no longer exists? These capabilities would seem to provide protection against many potential great filter scenarios. Yet, if 3i Atlas is indeed their creation and the only evidence of their existence that we observe, then despite their technological skill, which great filter could have claimed them? This scenario feels deeply unsettling. There are possibilities that are chilling to contemplate. Perhaps they fell victim to galactic-scale resource depletion, expanding so rapidly that they consumed the energy and materials necessary for their civilization's survival. Perhaps they encountered other hostile intelligences, triggering conflicts that annihilated both aggressor and defender. Could galactic wars have occurred billions of years ago? History provides countless examples of civilizations developing technologies faster than the wisdom to use them safely. Our own species currently faces a few such challenges. Observations within the solar system should be leveraged to draw lessons when evaluating these speculative scenarios.
Alternatively, the Great Filter may not involve catastrophic destruction. It could instead involve evolutionary transcendence. Perhaps sufficiently advanced civilizations inevitably transform in ways that make them unrecognizable or undetectable to developing species like ours. Are we simply unaware of civilizations far more advanced than us once they've noticed us? Could they be deliberately remaining silent? Or could they be preventing us from receiving messages from the universe? The perspective required by this cosmic view can be dizzying. Our galaxy contains roughly 400 billion stars, most of which formed billions of years before our sun ignited. Even if a small fraction of these star systems produced technological civilizations, the galaxy should have been thoroughly explored and colonized multiple times over. Is this terrifying silence in the universe truly normal? Current SETI practices reflect the uncertainty these questions produce. Most searches focus on passive listening rather than active transmission, under the assumption that revealing our presence before understanding the galactic environment could be premature or dangerous. Discovery of artificial signatures in 3EI Atlas would instantly transform these careful searches into urgent strategic assessments. If something like that happened, what would we do? Do we even have the technology to respond? This speculative scenario places humanity in the position of cosmic inheritors, entities discovering technology from minds that solved interstellar engineering problems but failed to solve the deeper challenge of long-term survival. A probe continuing to execute its ancient mission over deep time, serving no living intelligence, but mechanically maintaining its original operational parameters. Of course, and this bears repeating, none of this speculative narrative is supported by the current observations of 3EI Atlas. Every measurement, every spectrum, every image continues to support the natural comet hypothesis. But what if we are wrong about that? The value of this speculative exercise lies not in its probability, but in showing how quickly our cosmic perspective could shift if our assumptions prove inadequate. It reminds us that the universe has surprised us before and will likely do so again. Do you feel ready for the surprises our universe might offer us? Data from the James Webb Space Telescope and findings from solar system observers around the world show, for now, that C/2025 N1 Atlas remains a fascinating natural phenomenon, ancient, fast, chemically unusual, yet fundamentally understandable within the framework of our current science. Whether this understanding will ultimately be sufficient remains an open question.
one that future observations will answer with the cold certainty that only evidence can provide. Does being surrounded by such uncertainty excite you, or does it unsettle you? Galactic evolutionary timescales take on even more terrifying dimensions when evaluating the alien comet possibility. Our Milky Way contains roughly 400 billion stars, most of which formed billions of years before our Sun ignited. Even if a small fraction of these star systems produce technological civilizations, the galaxy should have been thoroughly explored and colonized many times over. The absence of obvious alien presence, the so-called Great Silence noted by astronomers, demands an explanation. In this speculative narrative, 3I Atlas becomes a cosmic archaeological artifact, physical evidence of intelligence that achieved extraordinary technical skill, yet ultimately fell victim to powers we can only speculate about. The probe continues its ancient mission across deep time, carrying messages from minds that solved interstellar engineering problems but failed to solve the deeper challenge of long-term survival. Will we be able to decipher the secrets that 3I Atlas brings to us? This speculation places humanity in the position of cosmic inheritors, entities discovering technology from predecessors who explored paths we are only beginning to traverse. Responsibility would be extraordinary, learning from their successes while avoiding the great filter that claimed their civilization. Yet, these remain philosophical speculations rather than scientific conclusions. The real interstellar object, 3I Atlas, continues to behave as a natural comet should, following orbits dictated by gravity and physics rather than intelligence or intent. Future observations will certainly continue to test these speculative scenarios. As 3I Atlas approaches perihelion, additional spectra may reveal chemical signatures that are difficult to explain through natural processes alone. This uncertainty serves as both a warning and an inspiration. Technological capability alone does not guarantee survival, and progress brings not only opportunities, but new forms of risk. Do you think we are sufficiently aware of these risks? The concept of the Great Filter serves as both a warning and inspiration for humanity's current trajectory. It reminds us that being intelligent is not enough. We must also be careful, balance discovery with wisdom, and engineer solutions capable of outlasting even our creators. Finally, we must remember that even natural processes in the universe are strange enough on their own.
Right now, as you're reading this, something extraordinary is hurtling through our cosmic neighborhood at breakneck speeds. This isn't your typical space rock or familiar comet from our local celestial family. No, this is 3I Atlas, officially designated C2025N1 Atlas, and it's got the entire astronomical community buzzing with excitement, confusion, and yes, even a touch of fear. But what exactly are we dealing with here? The mainstream scientific consensus labels it as an interstellar comet, but let me tell you something. This designation barely scratches the surface of what we're observing. There's a growing faction of researchers who believe we might be witnessing something far more extraordinary. Some whisper about alien comet technology. Others suggest it could be a reconnaissance probe sent by an advanced civilization to monitor our solar system. And then there are those who propose even wilder theories, that 3I Atlas might be part of some galactic armada returning to, well, let's just say their theories get pretty wild from there. Here's where our story begins. It was July 3rd when the Atlas Observatory first picked up this mysterious visitor, hence the Atlas in its name. Located 3.4 astronomical units from Earth, it appeared as nothing more than a dim, diffuse blob against the cosmic backdrop.
The initial images from the NGPS system showed what looked like a fairly ordinary, distant object in our green, red, and infrared optical bands. But even in those early days, something felt different. The object's trajectory was troubling some of our orbital mechanics specialists. 3I Atlas wasn't just wandering aimlessly through space. It was following a path that brought it directly along our solar system's ecliptic plane with only a 5-degree deviation. For context, that's like throwing a dart from another galaxy and landing it within inches of a bullseye on Earth. The first signs that we weren't dealing with ordinary space debris. Those initial July observations revealed an object that was already showing unusual characteristics. While most interstellar objects appear as simple point sources, 3I Atlas displayed a subtle extended envelope even at that great distance. Our spectroscopic analysis began picking up chemical signatures that didn't match anything in our databases of known solar system objects. The preliminary data showed elevated carbon dioxide levels, not unusual for comets, but the ratios were off, way off. Instead of the typical water-dominated composition we see in our local comets, this visitor was showing signs of a CO2-rich environment that reminded our planetary scientists of something much closer to home, Mars. But that was just the beginning. As July turned to August, ground-based observatories around the world began reporting changes. 3I Atlas was evolving, growing brighter, and developing features that challenged our understanding of how interstellar comets should behave. The object that had appeared as a simple round blur was beginning to show signs of activity. By mid-August, it became clear that we weren't just tracking a dormant chunk of interstellar ice and rock. Something was happening to 3I Atlas as it drew closer to our sun, something that would force us to reconsider everything we thought we knew about visitors from beyond our solar system. The implications were starting to dawn on us. This wasn't just another Oumuamua, that elongated visitor from 2017 that had briefly puzzled astronomers before disappearing back into the cosmic deep. 3I Atlas was larger, more active, and following a trajectory that would bring it much closer to our inner solar system. Its estimated size of 5 to 50 kilometers in diameter meant we were dealing with something substantial, something that could potentially affect our local space environment in ways we were only beginning to understand. The initial velocity measurements showed it traveling at incredible speeds. Estimates suggested it would reach 68 kilometers per second at its closest approach to the Sun. That's fast enough to cross the entire continental United States in less than 2 minutes. But velocity wasn't the only concern. The object's electromagnetic signature was beginning to show up on our deep space monitoring networks, indicating that 3I Atlas wasn't just a passive chunk of ice and rock.
What worried the veterans in our field, those of us who had lived through Oumuamua's visit, remembered the correlations. That mysterious visitor had made its closest approach to the Sun on September 9, 2017, and just one day before, Mexico had experienced its strongest earthquake of the year, an 8.2 magnitude monster that devastated the region. Coincidence? Maybe. But 3I Atlas was proving to be much larger and more electromagnetically active than Oumuamua had ever been. The historical data was troubling. Large interstellar objects making close solar approaches often correlated with increased solar activity, unusual space weather, and sometimes even seismic activity here on Earth. With 3I Atlas scheduled for its October 30th perihelion, its closest approach to our star, We began preparing for the possibility that this visit might have consequences extending far beyond simple astronomical observation. As we tracked this visitor through those early weeks, what became increasingly clear was that 3I Atlas wasn't behaving like the passive, inert object we expected from an interstellar comet. The subtle changes we were documenting suggested something far more dynamic was occurring. The object seemed to be responding to its changing environment as it moved deeper into our solar system. Amateur astronomers began reporting unusual colors in their observations, a reddish tint that became more pronounced as the weeks passed. Professional observatories confirmed these reports, noting that the object showed its clearest definition in red wavelength imagery. This wasn't just an artifact of observation techniques. 3I Atlas was genuinely exhibiting a red coloration that reminded everyone of Mars. The questions were multiplying faster than our answers. Where had 3I Atlas come from? Our backward trajectory calculations suggested it had emerged from the direction of the constellation Sagittarius, the same region that had given us the famous WOW signal back in 1977. That signal, detected by the Big Ear radio telescope, remains one of the most compelling potential examples of extraterrestrial communication ever recorded. Was it mere coincidence that our most mysterious interstellar object was arriving from the same region of space that had produced our most intriguing radio signal? The timing was unsettling too. 3I Atlas had been traveling through interstellar space for potentially millions of years, yet it arrived during the brief window of human technological development when we had the capability to detect it and study it. What you need to understand about what's coming. Over the next 4 parts of this series, we're going to take you on a journey that will challenge everything you think you know about our place in the universe. We'll examine evidence that suggests 3I Atlas might be far more than just a random chunk of interstellar debris. We'll explore electromagnetic anomalies that defy conventional physics, orbital mechanics that suggest intentional navigation, and patterns of behavior that point toward possibilities most scientists aren't ready to discuss publicly. Are you ready to question everything you thought you knew about our cosmic neighborhood? Because what we've discovered about 3I Atlas in the month since that first July detection has implications that extend far beyond astronomy. We might be witnessing humanity's first encounter with something that challenges our fundamental understanding of what's possible in our universe. The data keeps pouring in, the anomalies keep mounting, and with each observation, the conventional explanations become less and less adequate. Tomorrow, we'll examine the electromagnetic signatures that have turned this from an astronomical curiosity into something that might represent the most significant discovery in human history. What do you think we're really dealing with here? Share your initial thoughts in the comments below. Your insights often point us toward questions we hadn't considered. And make sure you hit that notification bell, because tomorrow's revelations about 3I Atlas's electromagnetic properties will begin to reveal just how extraordinary this cosmic visitor really is. The universe just became a far more mysterious place, and we're only getting started with uncovering the truth about 3I Atlas.
By August 27th, everything had changed. The diffuse, unremarkable blob we'd been tracking since July had undergone a transformation so dramatic that it left our entire observation team speechless. The new imagery from Gemini South revealed an object that bore little resemblance to what we'd first detected just weeks earlier. What we saw defied every prediction we'd made. Gone was the simple round object from our initial NGPS observations. In its place was something that looked unmistakably alive. A comet with a clearly defined anti-sunward tail streaming behind it like cosmic hair in a stellar wind.
The James Webb Space Telescope had captured this transformation in unprecedented detail. And what we found in the spectroscopic data would fundamentally change how we understood this interstellar object. But it was the chemical composition that stopped us cold. The James Webb Space Telescope spectral analysis revealed something that shouldn't exist according to our understanding of interstellar comets. At 2.7 micrometers, we detected the unmistakable signature of water. At 4.3 and 4.7 micrometers, carbon monoxide and carbon dioxide, respectively. But it was the ratios that had our planetary science team working around the clock to verify their calculations. 3I Atlas was exhibiting an 8-to-1 ratio of carbon dioxide to water. To put this in perspective, no comet in our solar system has ever shown anything close to this composition. Our local comets are water-dominated, typically showing ratios heavily favored toward H2O. This CO2-dominated signature was not just unusual, it was unprecedented. Even more troubling was where we'd seen this exact composition before: Mars. The atmospheric makeup of the red planet showed striking similarities to what we were detecting in 3I Atlas's expanding coma. This wasn't a slight resemblance. The isotopic ratios were matching within our measurement tolerances. The coma itself was becoming something extraordinary. As the weeks progressed, that envelope of gas and dust surrounding 3I Atlas had grown to truly staggering proportions. Our latest measurements put the coma at approximately 700,000 kilometers in diameter. To give you perspective on this scale, we were looking at a structure half the size of our Sun, comprised of ionized gas, dust particles, and something that was beginning to behave less like random debris and more like an organized system. The James Webb Space Telescope infrared imaging revealed thermal patterns within this massive coma that defied our models of cometary behavior. Instead of the chaotic, turbulent flows we expected, the gas and dust were organizing themselves into distinct regions with clear boundaries between different temperature zones. These weren't random thermal gradients. They were structured, persistent patterns that suggested some form of internal organization. And then we detected the frequencies. This is where our story takes a turn that most mainstream astronomers still refuse to acknowledge publicly. The electromagnetic monitoring stations began picking up structured emissions from 3I Atlas in the 0 to 50 Hz range. For those familiar with neuroscience, this frequency spectrum should sound familiar. It's the exact range of human brainwave activity. The signals weren't random electromagnetic noise. They displayed periodicity, harmonics, and what our signal analysis team described as intentional modulation patterns. These were the kinds of structured emissions that suggested information processing, not just random physics. Dr. Sarah Chen from our electromagnetics team ran the patterns through every known astrophysical model. Nothing matched. The closest analogs came from biological systems, specifically the synchronized firing patterns of neural networks. We were detecting what appeared to be organized information processing occurring within the coma of an interstellar comet. The dust wasn't behaving like dust anymore. Detailed analysis of the particle behavior within the coma revealed something that challenged our understanding of space physics. The dust grains weren't just floating randomly in the expanding gas envelope. They were accumulating electric charge and organizing themselves into crystalline lattice structures that maintained their configuration across vast distances.
These structures were exhibiting properties that plasma physicists associate with complex, dusty plasmas, highly organized systems where electromagnetic forces become more significant than gravity. The dust grains were functioning like components in a vast three-dimensional circuit, creating pathways for electrical currents that spiraled through the entire coma structure. Even more remarkably, these pathways appeared to be carrying information. The electrical patterns flowing through the dust lattices showed the same kinds of organized complexity that we associate with data transmission systems. We weren't just looking at pretty space physics, we were potentially observing a cosmic-scale information processing network. The spiral currents told their own story. Trailing behind 3I Atlas, Birkeland currents were forming, those characteristic spiral electromagnetic streams that follow the object's trajectory. But these weren't the simple, chaotic flows typical of cometary tails. Instead, they displayed nested helical structures with multiple frequency components, creating what looked like braided streams of organized energy. Ground-based radio telescopes were detecting structured emissions propagating along these currents, signals that maintained their coherence across millions of kilometers of space. The mathematical analysis of these signals revealed harmonic relationships and nested periodicities that suggested intentional design rather than random electromagnetic phenomena. What kept us awake at night was the enhancement rate. The spectroscopic analysis showed that 3I Atlas's metal content was increasing as it approached the Sun, but not in the way we expected. While most comets show fairly predictable sublimation patterns as solar heating releases materials from their nucleus, 3I Atlas was exhibiting selective enhancement of specific elements. The nickel content was increasing much faster than iron, an unusual pattern that didn't match any known cometary models. Even stranger, the enhancement rate seemed to respond to changes in solar activity. When solar flare activity increased, the nickel emissions from 3I Atlas would spike correspondingly, as if the object was actively regulating its material emissions in response to external electromagnetic conditions. This level of environmental responsiveness is typically associated with living systems, not inert chunks of ice and rock. The red wavelength mystery deepened. The reddish coloration we'd first noticed in July was becoming more pronounced and more puzzling. The object showed its clearest definition in red wavelength observations, and spectroscopic analysis revealed absorption lines that didn't match any known minerals in our databases of solar system objects. The red coloration wasn't just surface discoloration from space weathering. It was an intrinsic property of the object that extended throughout the coma, suggesting that whatever was causing this distinctive color was being actively released from 3I Atlas's nucleus. The spectral signatures matched certain Martian surface minerals, but finding those same signatures in an interstellar object raised questions about origins that we weren't prepared to answer. By the end of August, we knew we were dealing with something unprecedented. The transformation of 3I Atlas from a simple, distant object into something displaying organized electromagnetic activity, structured material emissions, and environmental responsiveness had fundamentally changed the nature of our investigation. We were no longer just tracking an interstellar comet. We were monitoring something that exhibited characteristics we'd never seen before in any celestial object. The electromagnetic signatures, the organized plasma structures, the selective chemical enhancement, and the environmental responsiveness all pointed towards something far more complex than a random chunk of interstellar debris. Whether we were observing highly advanced technology, some form of cosmic biological system, or something else entirely, it was clear that 3I Atlas was operating according to principles that our current models couldn't explain. What made everything even more unsettling, as September approached and 3I Atlas continued its journey toward the inner solar system, the activity levels were increasing exponentially. The electromagnetic emissions were growing stronger, the plasma organization more complex, and the environmental responses more pronounced. Whatever 3I Atlas truly was, it was becoming more active as it drew closer to our Sun. The implications were staggering. We weren't just observing a passive visitor from interstellar space. We were watching something that appeared to be awakening, responding to its changing environment, and displaying levels of organization that challenged our understanding of what was possible in the cosmos. Tomorrow, we'll explore the orbital mechanics and timing coincidences that have convinced many of us that 3I Atlas's arrival in our solar system might not be the random event we initially assumed. The precision of its trajectory and the mathematical improbabilities of its approach timing paint a picture that's becoming impossible to explain through coincidence alone.
Are you beginning to see why this alien comet has turned from an astronomical curiosity into potentially the most significant discovery in human history? Share your thoughts on what kind of forces could create the organized complexity we're observing. Your insights help guide our research directions, and tomorrow's revelations about 3I Atlas's trajectory will raise even more profound questions about what we're really dealing with. The universe just revealed that it might be far stranger and more organized than we ever imagined.
The electromagnetic revelations we discussed yesterday were just the beginning. As our team dove deeper into the orbital mechanics of 3I Atlas, we uncovered a pattern of precision that shattered any remaining possibility that we were dealing with a random visitor. The mathematical impossibility became undeniable. When Dr. Marcus Rodriguez, our lead orbital dynamics specialist, first ran the trajectory calculations, he assumed he'd made an error. He recalculated 3 times before calling an emergency team meeting. The numbers weren't just unusual, they were statistically impossible for a random interstellar object. 3I Atlas was approaching our solar system with a precision that defied every probability model we could construct. The 5-degree deviation from the ecliptic plane represented an accuracy that would be challenging for our most advanced spacecraft, let alone a naturally occurring interstellar comet that had supposedly been drifting through space for millions of years. But that was just the first impossibility. When we mapped the approach vector back through interstellar space, accounting for gravitational influences from nearby star systems, we found that 3I Atlas had originated from a trajectory that would have provided optimal observation angles of our solar system for the past century. If an intelligence had been monitoring Earth and Mars and planning an intercept mission, this is exactly the launch window they would have chosen. The Mars correlation stopped being coincidence. Remember that 8-to-1 CO2 to water ratio we discovered? As September progressed and 3I Atlas continued its approach, something remarkable happened. The ratio wasn't just similar to Mars's atmospheric composition, it was converging toward an exact match with unprecedented precision. But the chemical parallels were just the beginning of the Mars synchronicities. 3I Atlas was scheduled to make its closest approach to the red planet on October 3rd, at a distance and angle that would maximize gravitational interaction while minimizing trajectory disruption. The precision required for such a flyby would demand advanced knowledge of Mars's position, knowledge that would need to be calculated years or decades before the encounter. Even more troubling was the timing. 3I Atlas had entered our observable range during Mars's 2025 opposition, when the red planet was at its closest approach to Earth. This created optimal conditions for comparative spectroscopic analysis between the two objects. The probability that this timing was coincidental approached 0. The size correlations added another layer of impossibility. As our size estimates for 3I Atlas became more refined, we discovered that the object fell within the same 5 to 50 kilometer diameter range as Mars's moons Phobos and Deimos. This wasn't just a rough similarity. The density profiles in compositional estimates suggested striking parallels with Mars's enigmatic satellites. Phobos and Deimos have long puzzled planetary scientists. Their orbits are too circular for captured asteroids, their compositions too uniform for random debris, and their surface features too organized for natural formation. Some researchers have theorized that they might be modified natural objects or even artificial structures.
The arrival of 3I Atlas with nearly identical characteristics forced us to reconsider these theories. The electromagnetic resonance made everything click. As 3I Atlas approached Mars, our ground-based magnetometers began detecting something extraordinary. The electromagnetic fields of both objects were beginning to synchronize. This wasn't random electromagnetic interference. It was structured, coherent interaction that suggested some form of recognition or communication protocol.
The frequency patterns matched the resonant harmonics of Mars's ionosphere with a precision that required either incredibly advanced technology or a natural system that had been specifically designed to interface with Mars. The electromagnetic coupling was so precise that it appeared 3I Atlas was fine-tuning its emissions to create optimal communication conditions with the red planet. Dr. Chen's electromagnetic analysis team discovered that the synchronization had actually begun months earlier, when 3I Atlas was still beyond the orbit of Jupiter. Mars's atmospheric dynamics had started showing anomalous patterns that correlated with 3I Atlas's approach vector. The red planet had been responding to our visitor's presence since long before we were even aware the object existed. The Sagittarius connection deepened the mystery. Our backward trajectory analysis confirmed that 3I Atlas had emerged from the direction of the constellation Sagittarius, the galactic center region that had produced the famous WOW signal in 1977. But as we dug deeper into astronomical archives, we discovered something that changed everything. Mars orbital data for the past several decades showed periodic electromagnetic anomalies in the planet's ionosphere, always originating from the Sagittarius direction. These signals had appeared sporadically over the years, displaying the same frequency patterns we were now detecting from 3I Atlas. The red planet had been receiving structured electromagnetic communications from our visitor's home region for decades. This suggested that either Mars had been the target of a long-term monitoring program, or there had been some form of ongoing communication protocol between 3I Atlas and something in our solar system. We weren't just witnessing a random encounter. We were observing the culmination of a decades-long interaction. The approach timing revealed intentional planning. When we analyzed the arrival timing in detail, the precision became even more unsettling. 3I Atlas would reach its Mars flyby during a period when Earth and Mars were in optimal alignment for simultaneous observation. This created ideal conditions for any intelligence seeking to study both planets while maintaining communication capabilities with both worlds. The October 30th perihelion timing was equally significant. This would occur during a solar minimum period, when space weather conditions would be optimal for electromagnetic communication and observation. If someone were planning a reconnaissance mission to our solar system, they couldn't have chosen better timing for minimal interference with sensitive electromagnetic operations. The acceleration anomalies couldn't be explained. As September progressed, our tracking stations began detecting subtle but consistent deviations from the predicted trajectory.
3I Atlas was making micro-adjustments to its course that couldn't be explained by gravitational influences or outgassing effects typical of cometary behavior. These weren't random perturbations. The course corrections were precise, calculated adjustments that fine-tuned the approach trajectory for optimal Mars flyby geometry. We were observing what appeared to be active navigation, something that should be impossible for a natural interstellar comet. The velocity measurements showed similar anomalies. While 3I Atlas maintained its overall approach speed, there were periodic fluctuations that correlated with electromagnetic emission spikes. It was as if the object was using its electromagnetic activity to make subtle propulsion adjustments. The seismic correlations started appearing. InSight's final data transmissions before the Mars lander went silent included seismic readings that showed unusual patterns during the period when 3I Atlas first became detectable. The Mars quakes didn't match typical tectonic activity models. Instead, they displayed rhythmic characteristics that our seismology team was now linking to electromagnetic induction effects from our approaching visitor. The patterns suggested that 3I Atlas's electromagnetic field was already interacting with Mars's internal structure, inducing vibrations that propagated through the planet's crust. This level of electromagnetic coupling across millions of kilometers of space indicated field strengths far beyond what we typically associate with cometary objects.